Dear friends, in this video we are going to discuss about conic section. The term conic section refers to the geometric shapes formed by the intersection of a plane with a cone. In this definition, the cone is not necessarily a right circular cone. There are many conic sections on the basis of the angle of cutting. In every case, the conic section is the section of a cone by a plane. The ancient Greek mathematician Apollonius, also known as great geometer, made significant contribution to the understanding of conic section around 200 BC. Apollonius explored the properties of ellipses, parabolas, and hyperbolas, categorizing them based on their unique characteristics. His groundbreaking work led to the foundation for later developments in mathematics, influencing renowned mathematicians like Kepler, Newton, and others. Later, the conic section continued to be an integral part of various branches of mathematics like physics, engineering, astronomy, and other branches. In this video, we will start our discussion basically focusing on the geometric approach of conic section. In mathematics, cone is defined as a three-dimensional surface, which is traced out by a straight line passing through a fixed point and moving around a fixed line. In this definition of cone, the straight line is called generator. The fixed point is called vertex and the fixed line is called axis. So, conic sections are the curves obtained when plane intersects the surface of a cone, basically the surface of a hollow doubled cone. There are altogether 8 types of conic section, including parallel lines. In the figure, 7 types are shown, but the one case, which is parallel line, is not shown in this figure. Since the cone itself can be a cylinder, this form will occur when the vertex is at infinity. In this case, we can see that parallel line is also a conic section. So, altogether, there are 8 types of conic section. 4 of them are non-degenerate and the remaining 4 are degenerate conic sections. A point. A point is a conic section obtained by intersection of a cone and a plane in which the plane touches the vertex and the plane is outside to the generator, means outside to the directrix. And also it is the limiting form of ellipse. A line. A straight line is a conic section obtained by intersection of a cone and a plane in which the plane touches the vertex and the plane touches the generator. Means the plane is tangent to the cone. It contains exactly one generator of the cone. It is also the limiting form of parabola. A pair of lines. A pair of line is also a conic section obtained by intersection of a cone and a plane in which the plane touches the vertex and the plane is inside to the generator, means towards the inside of directrix. In this case, the plane contains two generators of the cone, and it is also the limiting form of hyperbola. Circle. A circle is a conic section obtained by intersection of a cone and a plane in which the plane meets the vertex and the plane is at right angle with axis. Ellipse. Ellipse is a conic section obtained by intersection of a cone and a plane in which the plane meets the vertex and the plane is not at right angle with the axis. Parabola. A parabola is a conic section obtained by intersection of a cone and a plane in which the plane meets the vertex and the plane is parallel to the generator. Hyperbola. Hyperbola is a conic section obtained by intersection of a cone and a plane in which the plane meets the vertex and the plane is not parallel with the generator. The conic section can also be defined based on the angles with the cutting plane. Let's say alpha is the angle between generator and axis. Similarly, beta is the angle between plane and axis. Then the standard so-called non-degenerate conics can be defined based on alpha and beta. If beta equals to 90 degree, then the conic section is circle. If beta and alpha are equal, then it is parabola. And if beta is greater than alpha and which is less than 90 degree, then it is ellipse. And if alpha is greater than beta, then it is hyperbola. This definition can be used to explain degenerated conics as well. When the plane cuts the vertex of the cone, we will have following types of degenerated conics, which are point and lines. In this case, when beta is greater than alpha but less than 90 degree, then the section is a point. When beta and alpha are equal, then the section is a straight line. And when alpha is greater than beta, then the section is pair of intersecting lines. The conics can also be defined based on the eccentricity E. In the next video, we will discuss about details of eccentricity and other algebraic approach of the conic section. But in the figure, we can see that a circle of finite radius has an eccentricity 0 because it has infinitely distant directrix. And similarly, a straight line has eccentricity infinity. We can see that the distance from directrix is 0, therefore the eccentricity is infinity. So thank you very much for this video. In the next, we will discuss about algebraic approach of conic section.